Hey everyone, how are we doing? It is Thursday. We might do some Chapter 2 quiz for Stat 201. So that is the thing due tonight, among many things. But if you're here in the chat, you get to pick what we do. So always remember that if you're here, you get to say, hey, Brian, let's do this. I'm going to get Chapter 2 pulled up right here from Pearson. But if you're in the chat, say, hey. Put on a little music right here as we get started. Hey, Taylor, great to see you here. Mewbots in the chat. Let's throw you 500 points, Taylor, for being first right here. Blake, good to see you here. What questions do people have? Are you Stat 201? Are you 474? Are you 320? What questions do you have? Let me know. And let's see. I'm getting it pulled up right here. This is one of the 201. What do you want to do? Which question are you working on? Are you working on Blake? Good to see you. Muskin, good to see you too. Which ones are we working on here? Which ones are we working on? Let me see. Instructor tools. Working on the quiz for the fourth. Try to get the 100. Yeah, Taylor, let me know each question you're working on. Let's do each question. Taylor, let's get you that 100. I want to hear that you got 100 right here. Thank you, Taylor, for doing 4 tries on the quiz, getting a lot of practice. Which question? Just tell me the exact question, and we're going to work each question. We're going to make sure you have the right answers, and we're going to go over the theory for each question. Just say the question you're working on. Blake, you too, tell me the question you're working on, and we'll talk about it. We'll do the theory. I'm pulling up the questions here as we speak. Let's get that 100. Thank you for starting early right here. It's early in the day. We got a lot of time. Say, I'm working on the question that has this on it, and then we will get that 100. Let me know which one you're working on, and we will get that 100. We're going to get that 100. We're going to check the answers and be like, yes, yes, yes. We're going to learn the theory. Can I help the quiz right now? Of course, Blake, of course. Blake, you're welcome to too. Anyone who's got a problem, you say, this is the one I'm working on. Boom, we'll pull it up. We're going to do as many as we can right here. We're going to get tons of problems done. You name the question, we do it. Name the question, we shall do it. We'll play this one. The accompanying histogram shows the annual numbers of traffic fatalities and passenger cars. Woo! The accompanying histogram. Thank you. Perfect. Found it. Got it. Good. 6 minutes, 23 seconds in. Stat 201. Quiz 2. Traffic fatalities. Oh, yeah, let's do this. Here we go. Awesome. Thank you so much, Taylor, right there. Any questions you have, drop them in the chat. Fun topics. Click here to show the traffic fatality data. Okay, so this is a bunch of quantitative information with the year associated with it from 1975 to 2013. There's a bunch of gaps in the years. Interesting. Show the histogram. Whoa. The histogram of years is uniformly distributed, except for the gaps. There are gaps in this data, but it's a uniform distribution because it's flat. That's exactly what a uniform distribution looks like. Flat means uniform, one form. There are gaps because they didn't collect. They collect every 5 years to start, then they collect it every year. Then this shows somewhat right here. This is a somewhat, not as pronounced, but there's somewhat to this data over here. Like that's not so much outliers. This is the fatalities we see for traffic accidents. There's some slight this to the data. What word would we describe it? You could say it's got a little bit of, well, this one's a little wrong. The whole thing might be a little left, but it might have slight bimodality. This is gonna be a tricky one, Taylor. Good mentioning this one. It might, if we think of this as our monster man, what we got over here? Oh, this is the Stat 201. There were nearly 11,000 messages sent yesterday during class. Wow. I was amazed by that. It might be bimodal. Very interested. I haven't done this one yet. Monster man might be thinking that's his tail over there. So is it left skew? Is it bimodal? I don't know how they're going to talk about it here. Does Monster Man have a little Monster Man tail? Let's find out. Okay. How many years are included in the highlighted bar in the passenger's fatality histogram? How many years are included in the highlighted bar? And the plots, a group fatality has been highlighted, and the corresponding bars in the years in histogram are also highlighted. Okay. So the highlighted bars, I think, are 2. 1, 2. And then they're showing you that these are the traffic fatalities for those years. So if you look at the data, they should be very, very high. Notice how we have 25,000 and 27,000. Those are much higher. Traffic fatalities has actually been decreasing, but there's 2 highlighted years right there. And those are the 2 highest years, 25,000 or basically 26 and 27,000. And then we see it down here at the 26 and 27,000 bin. So there's 2 observations over here, and those are the 2 right there. I wish they had done the rest of this in green. They don't know how to color code. So there are 2 years highlighted. Which years are included in the highlighted bars? And then separate by a comma. Okay, cool. So the years that are included are going to be 1975 and 1980. Was it only 2? It is only 2. 1975 and 1980. The starting number on the bin indicates the first number. So since it starts right in 1975, that is going to be the starting number. It's 1975 through 1976, but it's whole numbers. So 1976 would start the next number. So it should be 1975, 1980. There we go. What do these histograms taken together say about the passenger car fatalities? Let's see. This is just a tiny bit. That's not enough information. That's only for 1975 and 1980. That is true, but I feel like we should use more information. There have been fewer passenger car fatalities more recently than in 1975 and 1980. That's a pretty good thing to understand right there. We did see that by looking at the histograms because they're showing you these 2 points right here, and then they're down here. So that is true. It can be assumed that the number of passenger car fatalities in each year's were between... No, we can't assume that. That would be what we call extrapolation. This is very, very false. The total number of passenger car fatalities per year from 1975 is between... No, that is the total number between this. No, this is showing for those years because they're just giving the 1975 and 1980. So there have been fewer passenger car fatalities since those years. The average number of passenger car fatalities from year from is between... No, we don't know the average. So that should be it. Woo! That was a tricky one. Good question right there, Taylor. Pretty good, pretty interesting way of looking at data. Which one are we going to do next? Pretty good one right there. Tricky stuff. Having to look at this and understand what they're showing you. Quantitative car fatalities, the years with gaps, and the uniform distribution up here. You're welcome, Taylor. Which one do you want to do next? You name it, we'll do it. We'll talk about it. If you notice, we're adding more context to this by kind of reviewing terms like uniform, gaps in the data, which deals with the shape, bimodal, maybe a little left skew, but maybe a little bit of bimodality, like 2 peaks. The question didn't even ask things like that, but we kind of helped ourselves understand the data better. I wish it color-coded this green. I don't know who did their color coding, but if they're coloring these years green and these years pink right there, I don't know why they'd color this purple right here. I have no idea. Which question shall we do next? Remember, if you're here, we do the questions you want, and we'll review and make sure you get them right. There's a lot of questions, so you never know which question you got. Someone in the future, Taylor, does anyone have a question like, yeah. No, keep dropping them, Taylor. I promise someone in the future, Taylor, is super excited that you're dropping all these questions. The company histogram shows the life expectancy of birth of 190 countries. Let's go find it. So, Taylor, someone watching this video later... Someone dropped this in the chat in the comments of the video. Thank you, Taylor. So if you're watching this, how many times do we at this? I'm going to say this at the start of this question. Maybe we'll get some thank you, Taylors. I have a lot of people say, oh my gosh, that saved me. Like I was trying to figure it out, and I went, and I found the video, and your question, Taylor, might help people. So feel free in the comments of this video to say thank you, Taylor. 190 country birth rates. Oh, Moskin right there already saying thank you, Taylor, for 100 points. Right there. Somebody's doing the same question right there, I bet, in the future and right now. So here we are. We've got the accompanying histogram shows the birth rates of 190 countries by an international health organization. Now, when we do histograms, we always describe blank, blank, blank of a histogram. We always describe blank, blank, blank of a histogram. What are the 3 things we describe for a histogram? Oh, I don't have the notes open anymore. The blank, so the blank of it, the blank of it, and the blank of it. What are the 3 things we describe? The shape, the center, the spread. Great job right there, Blake. The shape, the center, the spread. Yep. So shape is first because it will determine center and spread accordingly. So the shape of it is going to be things like the modality of it, how many peaks does it have. It's going to also be the skewness versus the symmetry, which is super important for center and spread. And then the last part of it's going to be outliers and gaps. So let's look at the shape of it. And how's the Monster Man look today? He kind of looks similar to the last one. Now, we have a saying here, right to the high, left to the low, whatever way the Monster Man's tail goes. And Monster Man's tail goes what direction here today? There's Monster Man. What way? Left right to the high, left to the low. And we're saying right side is high side, left side is low side. Make sure your numbers are properly aligned, and Monster Man has a low tail. So most definitely, this is left skew right there. Great job right there, Taylor and Blake. And Muskin, great work too. This is a left skewed distribution. It's not symmetric. Symmetric would mean you could divide it down the center, like our faces are pretty symmetric. So the proper measure, and I know it's not asking this, but the proper measure of center and spread accordingly would be what? If we have a skewed distribution, the center of this should be what, and the spread of this should be what? It's not asking this, but we're doing review right now. Since it's skewed, center should be this, and spread should be this. Review questions. 100 points for these. When you get to test, you'll be like, well, it's skewed. We should use the center of this and the spread of this. You'll know it like that. So since it's skewed distributions, we use kind of percentiles. So the center is going to be the 50th percentile, and the spread is going to be the distance from the 25th to the 75th percentile. So those are known as the what. The center will be the what, and the spread will be the what. Median is the center. Great job, Taylor, right there. And then IQR is the spread. And those are both based on percentiles. Great job right there, Blake. We got the power team right here. Blake and Taylor right there, and Muskin right there. All the points. Keep getting those points and keep answering those questions. So now it wants to know how many modes it has. Now, is that a second mode? No. It's really just one and maybe one there. So I could possibly see it saying between 80 and 82. But over here between 76 or 74 and 76 is a mode. So 74 and 76, but not 64 and 66. And it says 80 and 82, but there's more clearly a mode right here. Mode is where the strong part of the data is. Great job. There is a different variant. Let's go find that next variant. Hey, what's up, Jackson? Good to see you here. Let's find that variant of the question. This is this one right here. This or this. And we have a variant right here that says, report the IQR since the distribution is skewed. So let's go find that. We're going to change this up right here. Is this it right here? Wait. Is this, but mine was also answered with what we went over. Nice. Report the IQR. What would you expect? Here's another variant of it. So this is the same data. So now when you think about this right here, this is a really good question. I like this one because this question is talking about, we have a left skew distribution. So there's a variant on it. This is going to represent the mean. And this is going to represent the median. Now, the mean follows the skew. But this distribution is what right here? This distribution I've just drawn is very what? Here, I'll give you a hint by showing you this right here. This distribution is what right here? This distribution is what? We would call this distribution a what distribution because we can do that. Symmetric. Great job, Taylor, right there. Excellent work. So this is a symmetric distribution. Also, great job, Blake, right there. Now, the mean follows the skew, right? So if we have a distribution like this right here, which is closer to our picture we just had, it's not quite as skewed as, like, we're doing something similar, but it's a skewed distribution. So the median would be right here or somewhere, more technically over here. That's about 50% of the curve over here, 50% of our data, and 50% of our data over here. But then, and great job, Shiona, right there, 100 points. Keep those answers coming in. Check it out. Now, the mean is going to be lower or higher than the median on this. The mean follows the skew. The mean follows the skew. This is left skewed. Since it's left skewed, the mean will be what to the median? The mean will be what to the median? So since this is left skewed, the mean follows the skew. The mean will be what to the median? We'll put a left right here. This is left skew. Monster Man's tail is going to the left right there. Monster Man's tail is down there. And the mean will be less, exactly. So the mean is going to follow the skew. It follows the outliers. So that's a good review topic right there, that the mean follows the skew. If a distribution is left skew, the mean is going to be lower than the median because the low values, like if they're pulled in that direction, are going to pull the mean towards it. The median is just the 50th number. So if a number, or the 50th percentile, 50th number if we have, if that was the middle number. But this would not matter if we pull it down further. But great job right there, Blake. So since this is left skew, the median will be larger, so the mean will be lower because the distribution is skewed to the left. So if it's left skew, the mean will be lower, meaning the median will be larger. So choose the correct answer below. What should we use? What is the proper measure of center? Since it's skewed, just scream it with me. The distribution is skewed. The proper measure of center is what? Easy points on the test. You get to something like this. It's skewed. The center should be the what? The median. Jackson, you got those points in the chat. So the median should be used because the distribution is skewed. And we just did another one. Is there another life expectancy one? I think was that all of them right there? We might try to do, there's one more, but drop another up. Here we go right here. I think this is the last one right here. Thank you so much, Taylor, right there, asking all these questions. We found out there's a bunch of baby life expectancy questions or something, or annual birth rates things. I don't know. So right here, this is yours right here. Report the what. So I think we did this, Taylor. We were answering additional questions, right? Well, the only two answers for spread are what or what. There's a third one, range, but that includes outliers. But we only, when we talk about spread, we either use the this, traffic fatalities, the one about the, we did that one to start. We could do it again here, Jackson. But you can rewind the video too, but we could do it again if you want. The only two answers for spread are going to be what or what. The only two answers for spread are going to be what or what. Like if I say, what is the proper spread? The only two choices are going to be what? So you say a spread of data, we're asking how far do things deviate or a range of the something. So what are your only two things that are going through your mind when I say what's the proper spread? Ooh, we got to go right there. Yeah, Jackson. Yeah, and let me know if you're stuck on it. So and we'll do Muskins next right there. So Muscan is it? Tell me if I pronounce anything correct, and we'll get it correct. What are the only two answers for spread? So don't look at the answers of the question yet, but the only two answers that we could answer here for spread would be what or what. So spread of data is best represented as either this or this. Two answers. Two possible answers. If I say spread, you'd say, I'm picking between the this or the this. I'll give it a moment more. 100 points in the chatter if you get it. Don't worry about getting it wrong. We're here to practice. If I say, let's look at the spread of the day, you say, I'm going to pick between this or this. Spread of data. Hey, Adam, good to see you here. Do you remember how we can analyze spread of data? The spread of the data will be properly analyzed by either looking at the this for normal data or the this for skewed data. Spread of data, if data is normal, we would use what? Hint, how far things generally deviate from the mean. So the answer for the top one up here is going to look visually. Standard deviation or IQR, Blake, 100 points right there. You got it. Standard deviation or, so that's how far things standardly deviate from the mean. Generally, we draw 3 standard deviations. And then if it's skewed, we'd use IQR, which is the range of Q1 to Q3. So the bottom one down here is a skewed distribution with IQR. So important to know that, great job right there, Blake, that the skewed distributions use IQR, which is the range of the middle 50%, the interquarters, and the standard deviation is a standard deviation from the mean. Like how far do things generally deviate from the mean? Larger standard deviation would spread out your distribution more, so you'd see a bigger spread or a bigger range to the middle 50% with a bigger IQR. So the first thing we want to look at here is the shape of the distribution to see that it is skewed. Since it is skewed, we're going to use IQR. So report the IQR since it's skewed, and we've done it. And so questions like that can be pretty easy if we know, look at the shape. The shape then determines the proper spread. Spread is either IQR or standard deviation based on skewed is IQR, and more normal without outliers is going to be standard deviation. Muscan has the next one right here. An author collected times it took to run 4 miles on various courses during a 10 period. Let's check that out. Perfect question. Wayne Gretzky. Oh my gosh, stop that author tip. Wait, was that it? That's not it, right? We shall find it. Here we go. An author collected all 3 questions. I'm marking that last one. Okay. Here we go. Are you back now? I was back in Knoxville hanging out, running around campus. Now I'm back in Texas. Check it out. Wait, we're taking a watch this. You ready?
No time to chat, Brian. You got to get in the car. You got to get in the spaceship, Brian. Brian, stop screwing around, and we got to get you back to Texas. It's a Stat 201 crossover. Yeah, Rick and Morty season 6.
Woo! I spent a lot of time working on that, so I just want to do it whenever I can. Whenever I can do that for someone, I'm just gonna do it. Okay, let me mark this right here. That was a few weekends ago working on that. Okay, here we go. We've got an author collected. I don't know. It just makes me smile. Okay, an author collected their times it took them to run 4 miles on various courses during a 10-year period. Oh my gosh, 10 years. The accompanying histogram shows the times, describe the distribution, and summarize the important features. What is about running that might account for the shape of the histogram? You probably get better over time. Also, they're kind of they're running 4 miles, and they did it over 10 years. I mean, I'm not trying to... I don't know. Well, first off, anyone who runs, it's hard on your body. Like, runners probably, yeah. I weigh close to 200 pounds, so I kind of stopped running for my exercise because 200 pounds hitting the ground is not that comfortable after a while, even with good shoes. So, shout outs to all those runners, and anyone out there getting some physical exercise, shout outs to you. It's always good to do something healthy. Maybe Brian should start running again, but they're kind of hitting their maximum right here. They're kind of hitting a wall in their running, so they need to throw on some parachutes or do some more like long, slow distance runs or something. Like they need to break through and get to that next level and start running those 5-minute miles, sub 5 right there. That was really tough. But let's check this out right here. The shape of the distribution is very right skewed. The Monster Man tail right here. Let's go talk about our Monster Man. Monster Man, we say right to the high, left to the low, whatever way the Monster Man's tail goes. And there's a little bit of outliers-ish right here, but Monster Man's tail today is there to the right. So right to the high, left to the low, whatever way the Monster Man's tail goes. It's also unimodal. We just got one Monster Man head right there. So that is what we got going on with that histogram. So it's definitely right skewed, right to the high, whatever way the Monster Man's tail goes. And it also is unimodal. We see here one peak to the Monster Man right there. It is centered around, so we look towards the center of the distribution where the peak is at, and that's towards the 30s right there. Any answer near there is going to be right. So it looks like, ooh, we got some close answers. Let's check 30 to 31. Yeah, is there a 29? Let me check. Oh, yeah, that's 30 to 31. A little scared, but yeah, it's not going to be further over. Let me look. Ooh, 29 to 30? Oh, you got to be kidding me. That's a little mean. Yeah, 30 to 31. 29 to 30 that's a little mean because technically, like 30 is right where the peak is at. But if you look right there, I think they're pointing to this. And that is in the 30 to 31. And that's a little tricky. I do agree. That one, not liking that it puts 29 to 30 because that's a little close. With most observations, they're talking probably about the interquartile range right here. So if we think about with most, we're talking probably a range somewhere in here-ish. We'll re-highlight. Most observations are going to be probably contained about there. So 29 to 31, 29 to 32. So 29 to 32. 28 to 30 is too early at the start of this. 28 to 30 is going to be over here, and that's not most. 29 to 32, if we highlight right here, is most observations. So that's a lot of the observations right there. Probably even more than 50% of the observations is contained in that interval. So definitely it would agree with most. If you look at the last answer right here, 33 to 36, that's kind of a preposterous answer because there's no way 33 to 36 contains most of the observations. So that's just the tail of the distribution. What about might account for the shape of the histogram? The runner may have slowed down due to injury or aging. I probably think it's improvement. Well, I guess This is a scary one right here because this is a speculation question. So this is why I'm glad I'm doing this, because a lot of speculation, like possible answers. Select all that apply questions are often mean. This would not be a good test question. So this is one you could get wrong, but good thing we're doing it now so you'll know you get it right. Over a 10-year period, the runner may have slowed down due to injury or aging. That is theoretically possible. Over a 10-year period, the runner may have improved. That is theoretically possible. It is easier to run much slower than normal, but harder to run much faster than normal. It's a weird thing to say. It is easier to run much faster than normal. I think they're going for this. I think this is where you have to pick one of these. So I think it's saying, like, what people can run, it's easier to, like, slow down and have, like, a bad day. But with what the person usually runs, it'd be hard for them to say, I'm going to, like, they could run at any point a 50-minute mile or 50-minute 4 miles, but they'd probably never run. You can't run a 10-minute 4 mile. That'd be 2.5 for each mile. So I think they're getting at right here, it's easier to have, like, an off day than it is to, like, go world record time. This one would say it's easier to go world record time than to have an off day. So that should be right. I'm a little worried on this last one. The U.S. Census Bureau, cool, we'll do it next. A little worried, and I was right to be worried. Is it really that? Oh, you got to be kidding me. Really? Oh, wait, over a 10-year period, the runner's times may have improved? I don't like this question. That's ridiculous. That is ridiculous. Oh my gosh. Please, if you got this one wrong right here in your quiz, email me and I'll give you the points back. So if you're watching this right now, that is so ridiculous. I just completely absurd. Boo question. Boo. Email me if you got this one wrong. I will gladly refund you your points on that one. You did right there, Blake. Let me know. We can correct that. Do you want me to correct it right now, Blake? 2 seconds right here. If that's the one you missed, and that's like I'll go in here, Blake, and correct that right now. You're here. Close down my question on me. And then Taylor will do that one next right here. Blake, we're going to fix that for you. Boo. Boo that question. Let's see right here. Get that fixed up. Oh, no, wait, I think I may have gotten it right. Okay, Blake, let me know. I'm going to go back to the assignment manager. He did that one. Yeah, which one? The data. We do that one next right here. Taylor's got track the number of adoptions. We can do adoptions right there. And then we can do the floods. We're going to keep doing that. Ban that question. Hashtag ban that question. New quote of the day. Hashtag ban that question coming up right here for you, Blake. Thank you, everyone, for being here. Sorry about that. New question this semester. Not a fan of it. Probably going to talk to Terry about it and say, what is this? Quote 282, ban that question. And we're getting the quiz pulled back up here. Let me know if you got that question wrong. That is totally unfair. And with that, let's go check out the next question right here. Brought to us by Taylor. Thank you so much, Taylor, right here. The next question is, the Census Bureau tracks the number of adoptions each state. Shows you that. So Census Bureau tracking adoptions. Let's go find that. Tell me if you see it on the screen as I'm doing this right here. Could we show the shoe question? Yeah, we can do the shoe question here coming up. Let me know the start of it. And we'll probably do that one next because we try to do as many different ones as we can. So Jackson will try to get to that one too. We have a good bit longer. We still have until like 12:40-ish Knoxville time. That goes a little bit over, but we still got a lot of time today. We're trying to find the Census Bureau. So we got a lot of time. So keep dropping those questions in. We're going to do as many of these as we can and try to get those 100. Here we go, the Census Bureau question. So let me take a note right here at the start of this and drop in the Census Bureau question. Start at 303, Stat 201, Quiz 2, Census Bureau. Let's check out the Census Bureau question. Okay, so let's look at this. Very quickly, you notice this is a what with what's. Just talk to me about the shape of this. If you see a histogram, you need to talk about the shape. If you see a histogram, you need to talk about the shape of it. Talk to me. Very quickly, we see what of this. You see a histogram, you need to talk to me about the shape of it. It's skewed. In what way, Mariah? Great job right there, Mariah. 100 points. It's skewed. And the direction of the skew is going to be very important for this question. I like this question so far. We're not banning this question. The skew of it is in what direction? Mariah, 100 points. Don't worry. Remember the saying, right to the high, left to the low, whatever way. Mariah, we're throwing you out. Mariah, we're throwing you out 500 points. We practice here in class to get it right. You ready? Say it with me in the chat for another 500 points. Right to the high, left to the low. You got to say the full saying, whatever way the monster man's tail goes. Right to the high. You got to say the full saying, left to the low for another 500 points. Whatever way the monster man's tail goes. Right to the high, left to the low side of the data. It's a 50-50 shot on the test. But we got to say right to the high, left to the low, whatever way the monster man's tail goes. So this is most definitely a what skewed distribution. Don't worry. We got tons of points right here for all that practice. Great job, Muscan, right there, too. So, we're throwing another 500 points. We're here to get some points. Thank you, Chiana, right there, too. So which way is this skewed? Most definitely it is skewed what? We're here to practice, so we get it right on the test. What way is this skewed? Most definitely it is skewed what? Right to the high, left to the low, whatever way the monster man's tail goes. It is most definitely skewed what? It is most definitely skewed what? We've got the answer on screen, but it's most definitely skewed what? Most definitely skewed what? To the right, Blake. Great job right there. Now, what did we just talk about when it comes to skew? If we have a distribution that is skewed, the what follows the skew. The what follows the skew. The what follows the skew. So what follows the skew of a distribution? Could show it like this. The mean follows the skew. So if the mean, the median is right here, the mean will go in what direction? The mean will be water to the median. Oh, that's my mean color right there. The median will be right here. There's the median, which is the 50th percentile. The mean will be water to the median here because the mean is going to follow the skew. The mean is going to follow the skew. So the mean will be water to the median. A symmetric distribution will have them on top of each other. But since this is skewed to the right, the mean will be water to the median. Remember, the mean follows the skew. So the mean will be water to the median. It'd be higher, Blake. You got it. That's right, because it follows the skew. So we're doing a color coding right here where the mean is represented, the position that it's at. We're just kind of estimating. I don't know the exact answers, but I'm just showing visually speaking for a symmetric distribution, mean and median are on top of each other at the center of the distribution, where for a right skew distribution, the median will be lower, median colored right here, and the mean is higher. For a left skew distribution, the mean follows the skew to the left, where the median is right here and the mean is pulled to the left. I think that'll answer most of our questions for this problem. Which would you expect to be larger? So since it's skewed to the right, the mean is going to be higher. The mean is larger because the distribution is right skewed. That's going to pull the mean to the right, so the mean is pulled towards the higher values. Choose the correct answer. Which of these right here? The median is resistance to the skewed shape of the distribution, so it is the better choice for summaries. Well, I think we just found it. I think it's got it. Yeah, first answer right there. What would be the proper, there's a follow-up question worth 100 points. That's the proper measure of center. Oh, yes, that is correct. I have two questions about, let's do that. You got it, Blake. So we got a few more. Keep those questions coming in. We got so much time today. What would be the proper measure of spread of this distribution? This is review. This is a right skewed distribution with outliers and gaps. It's unimodal also. The proper measure of center is the median. The proper measure of spread is the IQR. Blake, you got it right there. Great job, Blake. Let's do the next question right here, and we're just rocking and rolling through those questions. Rock and roll, Stat 201. I think the next question comes from, we just did the Census Bureau. There's that one. And then Jackson has this one right here. Let's do that. We'll do the flood question again. Jackson, thank you so much for being here. The accompanying table. So deaths from floods. Let's take that right here. And let's do the flood question. And then I think we have one more after this. And then we have Blake, your question. But we're just going to rock and roll, and this is practice right here. Stat 201, quiz 2, flood question. Let's go find that flood question real quick. The accompanying table. There's so many questions. Oh, is that yours? I think that was yours, right? Let's see right here. So many questions. Here we go. We got it. Okay, the flood question right here. We should be able to knock this one out pretty quickly. Okay. The accompanying table shows the annual number of deaths from floods in the U.S. states from 21 randomly selected years from 1940 to 2017. Write a short report describing the distribution of the number of deaths per year. Okay, let's take a look. Now, if you look at this, it's giving you, and there's, I think, some additional ones here where it asks you to find, so we might do those too, where it asks you to find the values in it. But this is quantitative or categorical. Just put a C or Q in the chat. Is this quantitative or categorical? Is that data right there quantitative or categorical? Quant or cat? It is most definitely what? Quant or cat? So I'm going to get her. It's quantitative. I'm going to get some data open right here. 2 seconds right here. I'm going to close down some stuff. 2 seconds. We're going to bring it over here to jump. Closing down some stuff. Closing down some stuff. Have jump open here a second. Closing down. So much stuff open. Almost there. 10 seconds. And I think I have done it. There we go. Everything's closed. Okay, good. Let me go back to that question now. And here we are. In 2015, nice job right there. We got Taylor and Muskin's question. We'll do those next, you bet. So we're going to take this data right here. We're going to copy it to the clipboard right here and hit Control-C or Command-C. That, once again, was clicking on the icon with the data, clicking the box right here, go copy to clipboard, and then hit Control or Command-C. Now, inside of Jump, you can have anything open inside of Jump right here by going to Jump and clicking inside of Jump and going to File, New, Data Table. File, New, Data Table. With File, New, Data Table, we can go right here and just go to Edit and then Paste. With Edit, Paste, we have now put the data into Jump. So now that we have the data inside of Jump, we can go ahead and take a look at it by clicking the shape right here. And now be careful. This is most definitely a what skewed distribution. This is most definitely, and look at the shape of it, that is most definitely a what skewed. Now be careful, you might get tricked by it. That is most definitely a what skewed distribution. This is a tricky one where I catch a lot of people, and so I'm glad we're doing it. Be very, very careful. That is a what skewed. Don't worry if you get it wrong, because this is the one that people make a mistake on. But remember, right to the high, left to the low. And so what way is that skewed? This is the one people make a mistake on if they see something like this. It is to the right. And so the left is the low. So this is the low side right here. You see how it's like low numbers? And this is high right here, the high numbers. So that's why I say left to the low, right to the high, whatever way the Monster Man tail goes. So this is definitely a Monster Man's tail going to the high side of the data right there. Now, the reason people make a common error right here on this is a lot of times when people bring in this distribution, they simply take this right here, but unfortunately their number line is reversed. So if they look at it this way, they say, oh, the tail goes to the left side, but now your number line, usually you put the low numbers on the left side of a number line. So in truth, if they're actually viewing it properly, they should flip their histogram this way, and it's very clearly right skewed because the higher numbers should go on the right side. Does that make sense there, Mariah? A very common error right here is to view it the wrong way, to be like, oh, it's left skewed because I just take my histogram right here and I just turn it sideways. And by turning it sideways like this, it's left skewed, but your number line is reversed. It should be flipped this way right here. Very common error right there. That's what we say, right to the high, left to the low. So remember, high numbers means larger numbers, low numbers means lower numbers, and left is lower numbers. That's got it for this question. Because now, since we know it is skewed to the right, that means, and it's unimodal, there are extreme values, and the most extreme value was the 555 right there is the most extreme. So really good question. We could come back and do the rest of these. I'll head over here, and we got more questions. Let's do a quick break right here. Awesome work when you get that next question loaded up right here. Excellent work, everybody. How's everyone doing today? We're already getting through a lot of questions. Has anyone gotten that 100 yet? Maybe you're here just practicing still, but has anyone gotten the 100 yet? Has anyone gotten those valuable 100s that we're always trying to go for in our class? Who has those 100s? We're going to get everything loaded up right here. There we go. And let's see. The next question, an investigator compiled information about the recent non-military plane crashes. Ooh, we haven't done that one yet. I love it. Not yet, but I'm planning Mariah. We're going to get this. An investigator, military plane crashes. Wish I could do like a search through the questions. Ah, here we go. Non-military plane crashes coming right up. We are just rock and rolling. Stat 201, quiz 2, non-military plane crashes. Here we go. Let's do it. I'm scared to submit. Oh, Taylor, let's knock this one out because I think you're working on this right here, right, Taylor? Let's check out your work. You ready? So submit after this one. You got this, Taylor. You got this. Okay. It is reasonable to conclude. Okay, we're looking at this. So pilot error is pretty much all the plane crashes. Hey, pilot error. Pilot error weather related, not good. Pilot error mechanical related. I guess this is like just the general pilot error, but then these are subcategories that they make an error during weather. They make an error due to a mechanical reading. So other human errors, and then mechanical failure is a big one too. So this is a frequency or relative frequency table. Relative frequency tables display for us categorical groups and show us the percent for each group. Is it reasonable to conclude that the weather or mechanical failures caused only about 19% of plane crashes? Okay, wait. So let's check out how much these add up to. 48, 19, 2, 5, 7, 12, 5. Ooh. I think they did some rounding right here, and I don't like that. Okay. So weather, is a reason to include that weather mechanical cost only about... No. No, because there is possibility of overlap between the groups. This is such a weird one. Why do the numbers add to 101? Yeah, I just saw that. Let's see. This is such a question right here. This one, Taylor, don't submit yet. I'm scared to submit on this one too. Is it reasonable to conclude that the weather or mechanical failures, here's weather, and there's mechanical failures. So mechanical weather or mechanical failures. Oh, wait, here it is. Weather or mechanical failures. Yeah. Caused only about 19% of recent plane crashes. Yes. Because there's no possibility for overlap. I think the cause, to the extent that could be determined, are summarized to... I think so. I had this one with a different version. I'll check out that different version here. And they're going to show down here the different categories, create an appropriate graphic. So A should have the most. So it's either going to be B. I'm doing the easy one right now. It's either going to be B or C. Trying to see the differences. Here, D has only a little. So the answer is going to be this one because D only has a little. If you see that D has a little, D has 5. D only has about 5%. A has the most, 48. So it's to pick between B and C with that information. It has to be C because right here, that one has only 5%, where over here, D has somewhere around 22%. Why did the numbers add to 101? Oh, that's the big question of the day, right? There must be an error in the data that this accounts for the extra percentage point. There must be is a wrong answer. There doesn't have to be. We're option rounding, right, Shreya? There doesn't have to be an error in the data. I think it's going to be probably like this. Is it going to be B? The data are given to the nearest whole percentage. If several of the categories rounded up an extra percent, that sounds... Shreya? My gosh, Shreya, with some top tier answers, that does sound right, doesn't it? The data are given to the nearest 100th... No, they're not given to 100th of a percent. So yeah, it looks like they're going between those two answers right there. I'm only worried about the first question. Woo! Don't be scared. Don't be scared. Because there's really no overlap. It looks like they've properly done this, but you'll see this sometimes with data. I've seen it before. So Shreya's seen it before where sometimes you get 101% because something like 47.8 is rounded up and 37.7 is rounded up. So it adds up, giving you another percent. But there shouldn't be overlap between these categories. That's the best way to make a bar chart. So if a bar chart adds to 100% of the data, then you probably don't have overlaps. Evan, great to see you here. We just did a hard question. Shreya helping us out. Shreya helping out with some 201. That's worth 500 points right here. I get scared with these new questions sometimes. We already had my Pearson try to trick us one time. And I think Muskin's got a question right here. In 2015, the Council of European Publishers reported the European School Survey Protection Project on alcohol and other drugs. Let's go find that one. So let's go find it. I think people are saying there's another one. The Council. Which questions do we have? Dang, I missed the fun. Oh, there's so much more fun, Evan. We're doing all the fun. I was super confused. Thank God for multiple attempts. Yeah, exactly right. The table to the right gives nice job, Blake. We'll do one next here. So we're looking for the drug-related one. The Council of Drug People. And then let's see out here. Gotta find the... I gotta put more music on between questions. So many questions. Where is it? Is it on the homework? After, can you do the version of the other plane crash? Yeah, let's check that out. Is it on the homework? Is the drug one on the homework? It might be. Yeah, let's take it. It's on the quiz. And it starts out, let me check that out on my skin again. It says in 2015, tell me if you see it. Be like, oh, Brian, it was this. We got it. Okay, here we go. Found it. Last question. The Wayne Gretzky, you got it. Taylor, let's check out. We're going to do a bunch right here. Okay. Take a note on this in 2015. Okay. 50, 55, Stat Tool 1, Quiz 2. I used to mark these later. In 2015, drug question. All right, here we go. Now, the data we have right here is what kind of data? Quantitative or categorical? Nice job, University Teacher. Thank you so much, everyone, for being here. Is this quantitative or categorical data? Is this quantitative or categorical data? Quantitative or categorical? Quantitative or categorical? This thing here. That thing right there. Percent used cannabis. It is... Blake's already got some answers in the chat. Is it categorical? So... These are for each country. Everyone's saying C, but in truth, it's quantitative because the question is, what percent of Albania has used cannabis? So if we ask someone, have you used cannabis? That's categorical. No worries, Blake. I ruined Blake's day. But Blake, cheer up, 100 points, cheer up. If we ask a person, have you used cannabis? That's categorical. If we say what percent of this country has used cannabis, that's quantitative. If I say report to me the percent, that's a number. But so it's a little different. It's like, have you used cannabis is categorical. Definitely said quantitative. I don't know what you're talking about. It's quantitative right there because that means it's actual real numbers. And the question was, what percent of this country has used cannabis? So since it's quantitative, tell me some ideas for how we could do graphics with it. Puppet Shark, you got ideas? He's got ideas. We don't do enough Puppet Shark these days. But what graphics could we use to display one quantitative variable? Because the question is, what percent of this country? A histogram. Ooh, I like that right there. Histogram, box plot, stem and leaf, dot plot. Got all those options, 100 points in the chat right there. You know what's up. So we got all these options right here to do it, and we only see two of them. We only see two histograms. This is a scatter plot for bivariate quantitative. This is a pie chart for univariate categorical. So the answer has to be B or C. Now notice how D has a bunch of answers down here in the lower values, where B only has very few answers in the lower values. You'll notice right here that there are a bunch of numbers like 5, 7, 4, 4, 7, 7, 7. And if there were that many sevens, we should see a higher peak, which we see over here. The answer is D. Which statement best describes the distribution? So what do you think? Ooh. Let's see right here. Now, the bimodality, I could maybe say, but it says bimodal with a center around 17 with most countries' values near 80%. That's not true. Bimodal with a center around 17 with a small number of countries reporting near 40%. Now that sounds accurate right there. Bimodal with a small amount of countries, boop, boop, and then this small amount near 40. That sounds right. Unimodal with most countries having exceeded 30%. That says if this is unimodal with most countries exceeding 30%, it's probably not unimodal because I really do see some bimodality. But if most countries have exceeded 30%, we would say most countries are over here, which is a false statement. So that eliminates the unimodal. So everyone knows how we're doing this with like process of elimination to say that, well, I do think it's bimodal. Like if I look at it, I say, yeah, it is bimodal. But if someone said, it's more like one mode, I'd say, it looks like two mountains. Yeah, and that looks like a right skew. Like the second mode has a little bit of a skew. Shreya with those top tier answers, knowing how to talk about our distributions. And so this is definitely some bimodality right here, I would say. And there are a few countries reporting near 40%. And that should do it. Check that answer. Get that 100. Okay, I think Blake had the next one right here. Keep those answers coming in, or keep those questions coming in. Little chill music right here as we get going. Blake's next question is, the table to the right gives the number of passengers car occupies killed in accident by type, by year, by type of car, by car type. And then I think we had another one we need to go back and do. Remind me of the next one. Here we go. We found it. That quick right there. So Stat 201, Quiz 2. Car table accident. Okay. Let's go check this out. Knock this question out. The more we do, the better we do. Took me a whole year. Nice job. Yeah, I know, right, Shreya? Shreya, you're doing great. I love it. So good to see everyone here. And there is, if those people don't know it, there is a Shreya level in the chat, so keep getting those points. We'll do another 500 points for people being here and practicing. Remember, talk every 15 minutes. Make sure you're getting the points. So reach that Shreya level right there. What level am I at these days? W for the win right there. So we need to make a relative frequency table. How can we make this into a relative frequency table? Now, what's really good is you can probably do this inside a jump pretty quickly. How many points am I at? I am at pirate tier. Got people at pog tier right there. Great job on those hours, everyone, too. So you just need to take these numbers and do what? You just need to take these numbers, find out the what, and do what? What would be the procedure for this? We want to make a relative frequency table. Find the total and divide each number by the total. So if I were to do this right here, you could do it in Excel too. You could go over to Jump, and in Jump, open a new data table, file, new data table, and that's pointers. Yep. And there's also points. And then we go to Edit, Paste with column names. And then inside of here, oh, no, don't paste with column names. Edit, paste. I stand corrected. Edit, paste. If you noticed, it pasted the column name at the start. So now we go right here and we go to Analyze Distribution. And with Analyze Distribution, oh, we can't do it that way? Yeah. We need to put Analyze the column 1 right there, which is the name of it. And then we need to put the frequency right here. And that should do it. So we've pasted it into Jump, and it's going to find all the values for us right there. One of the great things about using Jump, we can confirm our answer. So the total is the sum of all the values. I got 100. Besides the question that you said. Yeah, let me fix that here, Taylor. We'll fix that here next. Hang out between the in-between, and I'll fix it. Make sure you got those 100, so you won't need to email me too. We'll get to that 100. I can fix it pretty quickly here in the in-between, Taylor. But notice how we get the sum of these. And if you were to take something like 109 divided by 12,831, you get the following value right there. Now I think it's going to multiply these by 100. So let's go ahead and take our values. Jump made it nice and easy right here. It wants it as a percentage. So we're going to take the values. And there we go. Could you possibly help with chapters 2, number quiz 7? Is that 474? We could do some of that. You bet. People tell me if I make a typo right here. Please tell me. Typos are we're doing 2 decimals. That'll be a typo. Typos are where you're going to lose your points. I think that's got it. 0.85, 13.84, 29.46, 18.04, 37.81. No. I think that's got it. 37.81. Check that answer. No. What in the world? What in the world? What did I do? What happened here? What happened, everyone? 37.81, 18.04, 29.46. Did it change the numbers on me? Oh my gosh. Do you see it? It's not in the correct order. Meath right there. It's not. Ban this. No, it's just not in the correct order. Oh, man. Jump put it in a different order on us. Jump put it in a different order on us. So Jump said, here's your new order for the numbers. And so that's why we just need to change these orders. Oh, my gosh. User error. Okay. Unknown is correct. Full is going to be 18.04. Intermediate is going to be 29.46. Compact is going to be 37. I should have just done it by dividing the numbers by the total. And right here, 13 point. That was our only other one that was correct. Or no, that wasn't out of order. Hey, yep, we're doing some office hours for R and stuff later on. So that does it right here. There is the answers. You could have also found it. Probably would have been quicker because Jump put it in a different order. That's an error right there. You could take all the numbers right here and get the total. This is just a relative frequency table. There's the total. I feel like that's not the total. 12. No, it's the total. And then divide by. Great job there, Meath. Could we do the question that says the data accompanying deaths from a tornado 21 years? Yeah, Chiana. We could do that right there. And I think there's a few more. And Victoria, which one are you doing? 474? Oh, wait. Could you possibly go to chapter 2? Oh, the homework chapter 7. Yeah, let's do that one here. Well, how does that one read, Victoria? We might have it here on the quiz also, and so we could do the quiz version. Yeah, I know, right? There's so many mistakes to make. Here we'll do Chiana's question next. Thank you. We haven't done what? I don't think we've done one of your questions yet. So your question says the annual deaths from tornadoes. The annual deaths from tornadoes. So let me know which number it is. Annual tornado deaths. Okay. Let's see right here. A university teacher received an email from the students and directory entire team. Cool. And that's Muskin's question right there. Thank you so much, everyone, for being here. Here we go with the tornado deaths one. Now, this one is a little bit tricky, and there's two versions of it. This is a great question. 100 points for great question right here. Let's take the timestamp on it. This one is a little tricky, but don't worry, we're going to get an A. No mistakes. Not today, my person. So here we are on the tornado question, and the first thing I'm going to do is I'm going to bring this data into Jump to help me solve it. So let's go ahead and click this button right here, and then we're going to go to this button right here and copy to clipboard. And if you're on a Mac, hit Command-C. If you're on a PC, hit Control-C. Now that it's copied, we're going to go over here into Jump and go to anywhere in Jump. You can be anywhere inside of Jump. We're able to fix... Oh, let me do that real quick. Yes, Taylor. 2 seconds here. Thank you, Taylor, for reminding me. We're fixing something. I got that question wrong, Taylor, and my brain went boop and reset. 2 seconds here, Taylor. Thank you so much, everyone, for being here. Get those hundreds. And Taylor, it should show updated, and it should update in your grade book. So that should be good. You should be good to go, Taylor. Thank you for reminding me. Taylor, 500 points for reminding us right there. I'm going to restart this question real quick so everyone can see, and let's check it out. We're just going to do a re-timestamp, but Taylor, you should have that 100 great questions right there. Where did I... Oh, did I lose it? Close out the question. Okay. Let's see right here. Question 2. Replace questions. And it's towards the end. Tornado. There's the floods. Okay. I don't like it. It closes out when I change things. Here we go. Here we go. You're welcome, 100 points, Taylor. Thank you so much. And great work. Get those hundreds. That's what we're here to do. So let's re-timestamp right here. And now we're going to do the tornado question. Let's do it. Okay, so where are we going to bring this data? Does anyone know? 3-letter word. Where are we going to bring this data right here? I'm going to click this button right here. Where am I going to bring this data? We're going to bring it to jump. So we copy right here to clipboard. We hit Control or Command C on a Mac or a PC. We hit done, and then we go over here to jump. And when you're inside of jump, you can be anywhere inside of it. Go to the top on a Mac. Great job right there, Ben and everyone, and Rachel, good practice. We're going to go to File, New, Data Table. File, New, Data Table. Inside of the data table, you need to know if you're going to paste with column names or without column names. Now, there was no column name. Column name is like a word at the top of the column, giving it a name. There was no name at the top of the column, so I'm going to just hit paste. Watch out, if you paste with column names, it'll put the first thing in the column name, but we don't want the number up there. There was no name to the column, which would be something like tornado deaths. So we could name it if we want. These are all extra things right here, tornado deaths. This is a name to a column, and sometimes columns have names. If they have names, make sure to paste with those column names. Now that we have the tornado deaths in here, let's go ahead and take a look at this data. Try to zoom out a little bit. Can't. There we go. There we go. So this data right here, you'll notice, has some very high values. I'm going to go ahead and right-click it and go sort in ascending order. Now you can see that there's some extreme high values. Does that make sense? If there's extreme high values, the data is skewed to what side? If there's extreme high values, the data is skewed to what side? And I'll show you a hint right here as we do this. If there's extreme high values, the data is skewed to what side? If there's extreme high values, oh, Ben, no worries, 100 points, Ben. Right to the high, left to the low, whatever way the monster man's tail goes. So if we have extreme high values, the data is going to be a monster man right skew distribution. Extreme high values means monster man's tail is on the high side, right to the high, left to the low. Does that make sense right there? Right to the high, left to the low, whatever way the monster man's tail goes. Now, you have to be careful sometimes because you might see it looking like this right here, and people say, oh, that's left skew. But remember, it's high numbers there. The tail is going towards the higher numbers. Let's go ahead and look at our question right here. And our question starts out by asking us, trying to zoom out a little bit. Our question starts out by asking us, what is the mean of the data? So jump makes this nice and easy. You could add up all the numbers and divide by the total number of numbers. That's going to take a little bit of time to do. We're going to go here to analyze and then tabulate. I'll pause right here. Analyze, tabulate. Analyze, tabulate. Under Analyze, Tabulate, you want to take your tornado deaths column, or just the column that you have. It's blue because it's quantitative. Drop it right here. So I'm just dragging and dropping, and then drag the mean over sum. There you go. 144.57. 144. I'll repeat those steps. Analyze, tabulate. Make sure it's blue for quantitative. Make sure the numbers aren't up there, as in this is not a number. A meteorologist, Blake, let's do it next here. Then drag the tornado deaths right here, and then I think you can also drop mean right there. Well, it added the mean to it. Just make sure I take the mean. 144.57. So we go back here, and we enter in 144.57. Make sure to round correctly. Good stuff right there. Now, the next one asks about the mean, the Q1, the Q3, and the range of the data. These are a little bit more difficult to find, and Jump actually finds them a little bit differently, which the instructor tip mentions. So we're going to find these manually right here. Now, when you look at your data, if you have 21 observations, so you have 10 low numbers, 10 high numbers, the middle number would be the what-if number. So you have 10 low numbers, 10 high numbers. So at 21, the middle number is the what-if number. So the middle number would be the what-if number. Great job, Shrey, out there with those pro tips. The middle number will be the what-if number. If you have 10 low numbers and 10 high numbers, because there's 21 numbers, you can always find the position of the median by doing how many numbers you have plus 1 divided by 2. The middle number will be the what-if number. With 21 numbers, there's 10 low numbers, and there's 10 high numbers, so the middle number is the what-if number. If you were to put them in a line of numbers, the middle number of all this. What position is it in? 11th. You got it right there. So you can always take how many data points you have, 21 data points plus 1 divided by 2. That'll tell you the position. Does that make sense, Chiana, right there? This tells us the middle number is the 11th number right there. So the median is 59. Now, it's pretty easy to find out the max and the min since we have it sorted. Do remember I right-clicked and I sorted in ascending order. So I right-clicked, sorted in ascending order. You need to make sure they're sorted before doing this. So your data is sorted to find the median, and we have it right there. There's the median. We found the position of the middle number. To find the position of the middle number, you have 21 observations, 21 data points, plus 1 divided by 2. Number of observations plus 1 divided by 2 is to find the position of the median. Now, if you notice right here, these are things we wouldn't have you do on the test. We'd have you probably look at jump output, but the Q1 and the Q3 are basically the what's of the lower data. So think about this. Right here and right here are basically, I clicked the wrong spot right there, are basically the what's of the bottom 50% and the what of the top 50%. Like it's the what of those. So look right here where Q1 is at, and look right here where Q3 is at. Those are basically the what's and the what's of the upper and lower 50%. The median, yeah, it's like and they're the quarters, right? So now if you look at this, there's 4 numbers between here, 4 numbers between here, 4 numbers between here, 4 numbers between here. So it's divided up evenly. So we divide it up into quarters. Like if I were to slice this like as a pie or something, you could get 1/4 here, 1/4 here, 1/4 here, 1/4 here. And these are now put into quarters of the data where there's 4 quarters of the data. Yeah, you have 5 attempts, Jackson. That's great right there. Yep. Use those attempts, get those hundreds. That's what we like to do right there. And those should be the answers to the question. So we're going to bring this over here. And the median is the middle number. I'm going to try to make it big so we can all see the answers as we input it. So the median, there we go, we can see it. The median is going to be 59 right there. Let me disappear. The median is 59. The first quarter is the lower 25% is at 47. The Q3 is at 210. The range is going to be the max minus the min. So the formula for the range is going to be 553 minus 24. Oh my gosh, 553 minus 24. There it is right there. And then the IQR is going to be the range of the middle 50%. Who can find from the IQR right now? See if you can find it. Use the numbers on the screen to find the IQR. Just write it in the chat. Really good practice. This is how you'd often be tested on it, by giving data like this and showing the output and asking you to find the IQR from data like this. Remember, the IQR is the range of the middle 50%. Ben, great job right there, 100 points. So Ben is correct. Ben is just taking 210, which is Q3, minus 47. It's just a range, which is the distance those numbers are away. Like the range is the big number minus the small number for max minus min. Great job, Gianna, right there also. We should get 100. 100, we got it. So that's another one done right there. One of the more difficult ones because you have to do calculations, and there's another version of it, I think, right there. So make sure Jump does not find them accurately. You will need to find them using the class notes. Okay. A meteorologist preparing global walk. Let's check that out. Global walk. Next question here. Let's do it. A meteorologist. We got it. Look at that. We've done so many questions. We love it. Stat 201, quiz 2. Meteorologist. Preparing. Oh, we got it. Muskin, we'll do yours next. Let me write it down. The university teacher send an email because you asked it a few times. You got yours next. Thank you so much for repeating it. It is in the list. I got it right there, ready to go next. You got it. Thank you so much. 100 points. Here we go with the next question. Let's do this. So, a meteorologist is preparing a talk about global warming, compiled a list of weekly low temperatures. They misentered one of the data points where it was 36 degrees Fahrenheit, but they inadvertently entered 2 degrees, assuming that was listing all the temperatures. So they should have had a value of 36, but they moved it to 32. What would this look like visually? Well, so if they had their data right here, yeah, which one? Part 2, chapter, it's 201, right? How does the question start? Give me the start of the question. We'll see if we can find it. So here's their data. And this is an observation here. But they didn't enter it there. They misentered it down here. So it should have been around 37 degrees. But they misentered it at 2. So what is this going to change? What is that going to change right there? What is that going to change? So let's think about some measures right here. Would the range of the data be bigger or smaller? So the range of the data was this. What would the range of the data be now? So the range of the data is going to be what? They misentered. They should have entered in 37, but they didn't. So they didn't enter this value here. They didn't enter it there. They misentered it over on the left. So the range of this data now, because of the misentry, so their lowest point was misentered instead of 37 as 2. So this thing here doesn't exist. Like that point doesn't exist. It wouldn't. So what would happen to the range of the data? With this misentry, the range of the data is going to be water. So they entered it in as 2. So this is the original correct range. It's going to be a bigger range of data. So the range of the data still would have the highest high value, but I can't do it. There we go. The range is going to be much larger. Now, what about the IQR? The IQR is the range of the middle 50%. Well, the middle 50% might have been somewhere in here, but the IQR is going to be what? With the lowest value lower, will the IQR change? It will not be affected, right? Because the lowest value is outside of the IQR, so it's not affected. So the IQR is not impacted by outliers, right? Oh. Now let's look at other values here. Things like the mean. So the mean, and let me erase these things right here with our practice. The mean, might have been here, but the mean will be what now because of the lower value? The mean will be what now because of the lower value? The mean will be what now because of the lower value? With a lower value right there, the mean is the average of all the values. So if that value is lower, the mean will be water. This is the theory behind the whole problem we're solving. Yep, it'll be lower. But the median is the middle number. Is the middle number impacted by this? So the middle number, we move the lowest number lower. What happens to the middle number if the lowest number becomes lower? The middle number, like the number at the center, it's not going to be impacted. The median is not impacted by skew. So the median stays where it's at. And I think that's all that might be everything theoretically for this problem. The mean will be lower. The median will not be affected. The range will be higher, larger. The IQR will not be affected. And the standard deviation, So is standard deviation impacted by skew, yes or no? Standard deviation is how spread out the data is. So if we look at data with a small standard deviation versus a larger standard deviation large right here, larger versus standard deviation smaller, standard deviation is impacted by skew. So the standard deviation would be water now. Since it's more spread out, the standard deviation will be water. The standard deviation will definitely be water. Standard deviation will definitely be water. Because it's more spread out. Standard deviation is a measure of spread of your data, how far it's spread out from the mean. So it's more spread out. So the data is further spread out. So if it's more spread out, the standard deviation will be larger. So this is a really great question right here. That's a really good theoretical one. Great job, Blake, right there on 100 points. Gil's answers coming in. Muskin, let's do this next one right here. The question is, a university teacher saved every email. Okay, a little music. And then, Victoria, let's try to do your question here next. We'll just enough time for that. Get those hundreds. So many questions. Oh. Found it. Okay. University teacher saved every email. And this is currently at 118. All right, here we go. A university teacher saved every email from a students of a large email statistics class. I think I got, so let's check out question 7 on the homework. You got it, Victoria. Let's do that here next. Question 7 homework. Homework 2. Yeah, it's on the homework, right? We'll do that next, Victoria. You got it. Thank you so much for waiting this whole time. We're doing that next. Okay. So the accompanying histogram shows the distribution of emails from the students. Let's take a look at it. Wow. Wow. This is definitely a what distribution. Instantaneously, this is definitely a what distribution. This is definitely a what distribution. You can see it here in a second. Closing down programs. This is definitely a what distribution. That is most definitely a what distribution. Instantaneously, I see it. Skewed. It is most definitely a skewed distribution. Skewed to the right. So that is definitely skewed to the right, right to the high, left to the low, whatever the way the Monster Man's tail goes. That is definitely a right skew distribution right there. So it is right skewed. Skewed. You kill me, Blake. Ben, you're killing me. So we say skewed. The shape is definitely skewed to the right. It's also unimodal. Unimodal, skewed to the right. That looks right. There's so many options. Unimodal, skewed to the right. Hey, is there another version of this with more parts? Oh yeah, then we got another one right here. Okay, let's take a look. Another version of it. No worries. Yeah, it's just okay. Same, skewed to the right. The histogram is right skewed. That is true. So it's one of these two answers because it's right skewed. It was most common for students to send around 4 to 5 emails. Maybe there's an outlier at 21. The histogram is right skewed. It was most common for students to send 1 or 2 emails. Yeah, it's more common for 1 or 2. That's the modality of it. And most sent 5 or less. Yeah, that's true. 5 or less most. And then, yeah. They need to get some Discords, what they need to get. There we go. Good stuff. Good questions right there. Good stuff. Excellent work. Hopefully people getting those hundreds. Just looking at it, understanding how to interpret our data. I think I got class in 21 minutes. We're going to go over here and change screens. I'm going to send out an email. Boop. Okay, we're going to send out the email saying it's almost class time to BAS 474. They've got their activity today, activity part 2. And let me get their playlist up. Class in 20 minutes. And announcements, and then we're going to do the question right here. Thank you, everybody. Class in 20 minutes. See you soon. Click here. There we go. We got it. We're good to go. Change to only our section. And there we go. Let's get that homework up and going right here. And it's almost the weekend. Anyone got big plans for the weekend? What are you doing? What are your plans? My plans is to drink more coffee. I got bacon too. Gotta make that bacon. Good bacon stuff. We got homework 2. Place a question. Question number 7. Okay. Going to the state fair, that sounds fun. When it tells me to not use jump for the question, how do I do it? Oh, we were doing that earlier, Ben. Check it out. You can rewind the video right here. You're probably talking about the annual Tornado Desk one. We were doing that at 1 hour, 3 minutes in. Check out that portion of the video. We were doing solving it, putting it, and ordering it. I use jump to order it. I don't use jump to solve it because jump will come to the wrong answer, but check that out and let me know if you have problems. We put it in order and we found Q1 and Q3 using the order. So good questions right there. And we might be doing something similar on this question. Let's find out. Here we go with this question. Let's do it. Okay, so we got question 7 on the homework. We're going to work through the whole thing right here, but let's check it out. We've got right here the study on the body fat of 250 men is collected of 12 body parts, as well as the percent of body fat that men carried. The accompanying display is a dot plot of their bicep circumference in centimeters. Would you report the standard deviation or the IQR? Explain briefly. Now, standard deviation or IQR are measures of the spread of a distribution. So when we look at this right here, we'd ask, what is the shape of it? The shape determines the proper spread. Now, this is a little weird, but it's mostly modal. Mostly, I know, I see it. I was a little bloop. It's mostly modal. You mostly unimodal. And is it mostly symmetric? is it mostly symmetric? Symmetric means we can kind of cut it in half and it kind of looks like the same on the other side. Is it mostly symmetric? As we say, mostly, not perfectly, but mostly. Like if I draw over it like that, does that do a decent job? I'd say, yeah, decent. I know it's kind of tough. No data is perfect right here, but I'd say this is mostly unimodal, mostly symmetric. Like not perfectly. I know we might say, well, isn't that a second mode? And that's a little lookout point right there if you're climbing this mountain. There's probably just one mountain right here with a little bit of debris falling off. Because if this were to be leveled off right here, probably not. You can see the difference between standard deviation and IQR. I feel like I get it wrong all the time. IQR is going to be where the middle 50% is at. So 50% of the data is contained within this region, found between Q1 and Q3. So that's the 25th to the 75th percentile. Now, the standard deviation is usually seen as 3 units going up and down from the mean, used for normal data. So the proper measure of spread right here would be standard deviations. And so this is 1 standard deviation down, 2, and 3. So if data looks like this, usually we plot up and down 3 standard deviations. So standard deviations explain how far do things standardly deviate from the mean, and the mean would have no standard deviations away from itself. So we've got right here, great question right there, Paul. The standard deviation is how far do things standardly deviate from the mean, and that's a measure of spread used for normal data, where IQR is the range of the middle 50% used for skewed data. So since this data right here is somewhat normal, we'll do the standard deviation because it is symmetric. So it doesn't have any extreme outliers. It's mostly symmetric, and we have that right there. Oh, do we need to do another one on here? Victoria, does that have it? Is that good to go? Good questions right there. Should we do another one? This one's really tricky on number 8. We've done this one a few times, number 8. But let me know. We'll probably head off here in a second because I'm going to grab a little bit of lunch. But really want to say a huge thank you to everybody who was here today. I thought it was the IQR. That makes sense. Yeah, it's a tough one because it's mostly symmetric. And if you just got here, check out everything we did. We did so many quiz questions, lots of different versions. Check it out. Let us know if you're stuck on the Discord on something. A lot of quiz questions, a lot of homework questions, and lots of practice and talking through the theory behind each one. Try to answer the questions. And huge shout outs, 500 points for everyone who's been here in the chat, because it's all about just practicing to where you have to say, okay, if it's normal, I use the standard deviation for spread. If it's skewed, I use the IQR for spread. See, I was about to make a mistake there. So it's all about that practice and getting it just memorized and understanding it and why we do it. So with that, we're going to head over here to the main screen. Big thank you to everybody. It is that time to head off. But we'll be back here on Monday. We're going to do more streams later today. We're going to do a coding stream later. But with that, I will see everyone later. Bye for now, everyone. Bye. You're welcome. Bye, everybody. Bye, Blake.